They do change colors every season.
Right.
So
Yes.
one would assume that they have
multiple. Yeah, basic. So then I could believe that because to me, it's like if it were actually super useful, there'd be a whole black market for these bad boys. I want to hear about fireworks now because you promised fireworks.
All right.
And we haven't talked about them yet.
All right, let's go out with a bang.
Hello and welcome to I Should Have Known, the trivia game show that can't be trusted. Each week, one of our Quizmasters will present you with 4 facts about a topic, but one of them is a lie. And welcome to season 4. We are new and improved, I Should Have Known, and we are doing Rainbow for the month of June to celebrate our new season. And this week, our Quizmaster is Tanner.
Hello, that's me.
Yeah, it is. And Tanner's doing a sciencey episode about the chemistry of color. So he will present us with 4 facts about the chemistry behind colors, but one of his facts is a lie. So join me, Andi, and our other host, Sups, in trying to figure out which one it is.
First, we have our pub quiz question.
Yay, pub quiz!
Yeah.
Okay.
So this is a new feature for season 4, where we will present you with a pub quiz or trivia style question that you might hear at a pub quiz or trivia event if you go.
That's right. So, what is the name and chemical symbol of the noble gas which emits a reddish-orange glow when heated in a glass tube?
Oh, I associate blue with neon signs.
Ah, what is it?
It's neon,
Yes,
and it's NE.
that's right. Yes.
Correct.
And actually, all of the noble gases glow when you heat them, and they glow different colors. So,
See, that's why I was confused because
Yeah.
I was like, I know they're different colors. So I was like, oh no, which one is it going to be?
yeah.
I don't know the reddish orange ones because I didn't think that was neon.
Yeah, it's neon. So that's the most common one. If it's blue, that's probably xenon or argon.
Huh.
Yeah. So today we're talking about leaves, crabs,
Oh, crabs.
water, and fireworks.
Okay.
I love that crabs are involved.
Yeah.
I don't know what crabs have anything to do with color
Stay
chemistry,
tuned.
but okay.
All right.
Fact number 1. Leaves naturally have 3 color pigments.
Okay.
Okay. They do change colors every season.
Right.
So
Yes,
one would assume that they have
they have multiple. But what I find interesting though is when you say like pigments, that means giving color. So sometimes the color that you see is from like a lack of something else.
Right.
But then I'm also thinking like, don't most things have 3 pigment colors? Isn't that how pigments work?
Yeah, you're too smart for this show.
Okay, I'm
you're
sorry.
the teacher's aide, I think. Yeah.
Andy, you're officially disqualified from season 4.
Oh, yeah. So the usual explanation of why leaves change color in the fall is that they die. And as they die, they change color from green to yellowish orange
Or to red or
red,
to purple.
and then brown,
They're different
and they
ones.
fall off.
Yeah.
Right? That's not exactly true. Leaves are actually changing the ratio of these 3 pigments they have in an active process in order to kind of salvage some of the elements and chemicals in their leaves, and then they actively make the leaf fall off.
Okay. And this is chlorophyll has got something to do with it?
Yes, that's the green one,
Yeah.
the most abundant one. That's why leaves are green in the summer
Yeah.
and spring, because most leaves have 3 pigments. Chlorophyll, which reflects green light because it absorbs other wavelengths. Carotenoids, which
Is
give
that orange or yellow?
carrots their color.
Yes.
Yes. They reflect orange and yellow. And then a third one, which reflects red and purple, is called anthocyanins.
Okay.
So most leaves have a ratio of these. And the most common one in the warm months is chlorophyll. But this pigment, it's kind of unstable. So as it gets colder, it quickly decomposes. And so the more stable orangish yellow carotenid is now the most common one in the ratio of
see.
3.
Okay.
And then finally anthocyanins, if there are many. And so this is why they change color in this way.
Okay. I can kind of believe this. I have always wondered why like cherry trees, they don't have green leaves, many cherry trees.
Right.
They have like reddish purplish leaves, normally.
Yes.
They're not like green leaves.
Yep.
I always thought that was weird and I wondered why. So I guess they just have a different ratio of this, assuming that you're not lying to me right now.
Yes.
Because you might be.
Yeah. So the lie could be it's not 3, but maybe there is one other pigment that we're forgetting. Or,
Yeah. Well, I would think that it's like the common knowledge would be about chlorophyll. Everyone knows about chlorophyll. And then I guess like the question is like, well, is chlorophyll pigment or is chlorophyll something else?
Yeah.
This could be true because it could just simply be like you never really thought about it. But like most things that we see that are pigmented is a combination. Pigments are like paints, like you think of paints, right? But then at the same time, it's like I also could just see that when chlorophyll breaks down, it turns orange or yellow. Like that could also just be true, I guess.
Yeah, makes sense. I mean, the logic, everything they said, I mean, vaguely reminds me of things I studied these in like middle high school bio, right? So I think, at least the 3 pigments, I heard of these names. I mean, chlorophyll, yes, but the other 2 also.
Yeah, I went to public school. I didn't hear about it. Okay. I definitely need to hear more before I can really guess.
So the next 3 facts are pretty much about blue because it's so rare.
Yeah.
So fact number 2, litmus tests are made from the blue blood of horseshoe crabs.
What? Okay, I did know that horseshoe crabs have blue blood, and it's super weird.
Yeah.
Remind us about litmus tests.
All right.
I did learn about those in my public school,
Good.
Yes.
so
Good. Okay.
I do know what those are.
Yes. So we'll start with litmus tests and then we'll come back to the crabs.
Okay.
Okay. Litmus paper is a type of paper that you can use as a basic test for pH.
Show's over.
Basic, yes.
You're basic.
So the litmus test is performed by this dyed paper. You place a small drop of a sample on it and it changes color. That's the idea. Now, a litmus paper is white and it has a blue end and a red end, usually nowadays. And the red end will turn blue if the sample is alkaline or more basic. And the blue part will turn red if the sample is more acidic.
So the whole thing will turn one color.
But horseshoe crabs, they have bright blue blood, and inside their blood, there's a collection of immune cells that are exceptionally sensitive to pH. So when these blue cells meet an acid, they flood the area with a solution of sodium bicarbonate, which we use in the kitchen as baking soda.
Yeah.
And it neutralizes it and turns it from blue to red.
Good job, students.
So going back to the fact about this blue blood and crab and litmus test. So are people actively seeking out these crabs to get this for
Their blood?
Yeah.
Yes.
Hardcore.
So they're still bled, like thousands of them per year, because they still need this chemical in the blood to make the paper.
And we haven't been able to synthesize it.
Scientists have been trying to replicate it in the lab by like cloning the cells for a long time, but they haven't been able to.
It's
yet.
2023. Come on, scientists.
Yeah.
It's interesting.
They like milk them.
Yeah.
Yeah. But that is really interesting, though, to think about. So it's like not vegan if you
Do a
work in a
litmus
chem
test?
lab.
Oh, yeah.
That's like weird to think about, though.
Yeah.
We haven't been able to make artificial horseshoe crab blood.
Okay.
Okay. When you say they're bled, they don't kill them. Is that what you're saying? They try to like take samples out without murdering them.
They try. Yeah. Some die every year.
Try.
Yeah. But they shove like a tube in them and the blood comes out and they try to stop before they die.
Did they also get a cookie after donating their blood?
Yeah. Okay. Oh, wow.
Okay. What an elaborate lie that was, if that was a lie, right?
That is so cool.
Like-
that's super cool. Like,
That's elaborate.
yeah.
Wow. I mean, okay. So a couple things. One thing is that how important are litmus tests actually in labs? You know what I mean? Like, I know in school, it's like
Yes.
you have to learn about pH, but like all the litmus test tells you is if it is a base or an acid. It doesn't tell you how acidic or how basic. I mean, you can kind of tell by the color, but like not precisely.
Right.
So like, why even bother making them?
Yeah.
Other than to teach kids about
That's basically the industry for them. Yeah, it's for high school and middle school chemistry. Yeah, because in the professional labs they have pH meters if you want to test your blood, you have an arterial blood gas.
You measure
don't
the
use these.
hydrogen. You're not going to like sit and
Yeah, you need an exact number. This just tells you what half it's on, you
Yeah.
know? Yeah.
Yeah, I
Interesting.
think it's like for kids between 12 to 16. I think that's the market.
Yeah. So then
Or very quick.
So then I could believe that because to me, it's like if it were actually super useful, there'd
Yeah.
be a whole black market for these bad boys, these
Sure.
poor little guys. But like if it's not that important, it's like, okay, yeah, people take what they need and
Yeah.
that's the end of it, I guess. Still surprising that I think like we're kind of as a species moving away from these kinds of things. So that seems a little sketchy. That like we haven't created a synthetic version of this.
That's what I find really hard
You
to
know?
believe. Yeah. Okay.
Okay.
But we're halfway there. So,
Yeah.
All right. Let's stick with blue and the water. So, fact number 3 the ocean is blue mainly because water absorbs red light.
Like en masse.
Yes.
Because like my cup of water is clear.
Yeah, that's exactly the question. Pure water is clear, but the water molecules, when you have enough of them,
Right.
they absorb red light the best. And so the deeper water you have, the bluer it is. So in your glass of water, it's not deep enough
right.
for the water molecules to absorb
Right.
enough red to appear blue.
That's what I was saying. That like when you have enough water like the ocean, then it's blue
Exactly.
because it absorbs red light.
Yes. As long as it's not reflecting off of the sea floor. So this is why coastal and shallow water
Right.
appears a different color.
That pretty
color, yeah.
like bluish green color
Turquoise,
is
like-
from the
Yeah.
sand on the bottom.
Exactly.
Yeah. Okay, so you're saying the ocean works like a t-shirt
Yeah.
or like
Yeah.
a painted wall.
Yeah.
Where it's literally like the waves are bouncing off or being absorbed and that's how we see them.
Exactly.
Yeah.
Yeah.
Okay.
Yeah.
I mean, I guess.
Sounds logical.
And then like the ocean is blue.
Mm-hmm.
So we can't really, that's
That's not a lie.
That's not
That's not
really
a
a
lie.
question.
Yeah.
I get that the idea is that like there's so much more water, that's why it appears blue, whereas like your cup of water does
Yeah.
not. But I don't know. It seems like a weird reason to me.
Mhm.
I don't know. Because like not all lakes appear blue. Is that how deep we gotta be?
Yeah. Yeah. That's what I'm thinking. And it's like, there are lakes where it's like almost clear water.
Yeah.
Right?
Like a
Yeah.
mountain
Yeah.
spring
Mhm.
lake
Mm-hmm.
can be pretty deep.
Yeah.
Like Lake Baikal is the deepest lake in the world. It's clear.
Clear.
Yeah.
Why would the ocean be blue? Is it really just like you need that much more water?
Yeah.
Yeah.
This is the first one where I'm like,
I know.
I don't know. I feel like there's going to be a different reason the ocean is blue.
Yeah.
I feel like it was too simple.
Yeah. Maybe that's
Why is the ocean blue?
It's blue just the same way your t-shirt's blue. Like, what?
Yeah, right.
No, I want it to be more profound. It's the ocean.
Yeah.
But okay. I don't know. We'll have to think of that. I want to hear about fireworks now because you promised fireworks.
All right.
And we haven't talked about them yet.
All right, let's go with a bang. So fact number 4. The most difficult color to create for fireworks is blue.
But like fire is blue.
Yes. But when you make colored fireworks that go up and explode in the night sky, you can make different colors using different elements.
Right.
By far, the most difficult one to make for fireworks manufacturers is the blue color.
Okay. So you mean of the colors that people use to make fireworks?
Yes.
Because I would imagine black would be pretty difficult
Sure.
to make a firework thing.
Yeah.
Okay.
Yeah.
So you're saying of the colors that people manufacture fireworks, blue is the most difficult of them.
Exactly.
Okay, well now that sounds much more believable. Because before I was like, I'm sorry, how is like black not harder? How do you make me a brown firework,
Yeah.
Tanner? Go ahead. I've seen blue ones, but I've never seen a brown firework.
Yeah.
Okay, I think I've heard this before. Maybe.
It comes up every 4th of July.
Yeah. Culturally, we have a lot of fireworks.
Yeah.
Okay, what is it? Nickel? What chemical makes blue?
Copper.
Copper, of course. Oh, I
So,
knew that.
yeah.
I should have known.
It's really cool when you get into fireworks. They're not just like a bunch of gunpowder. It's actually like a precise packaging of the shape that you want to appear in the sky in these little tiny stars that have mineral elements packed around, which have black powder or gunpowder surrounding it, and then like a fuel at the bottom. And so it's kind of like a ice cream cone shape. And the element that's wrapped around these little, they call them stars, that's what produces the colors. So copper makes blue, barium makes green, strontium makes red, and sodium makes yellow.
Okay.
And then you can mix those. Strontium and sodium makes orange. Copper and strontium makes purple. And titanium, zirconium, and magnesium makes whitish silver.
Cool.
But if you look at the periodic table, barium and strontium, these are on the far left. They're
Yes.
alkaline earth metals.
Uh-huh.
Copper is
On the other
in the
side.
middle. It's a transition metal.
Okay.
Okay. Why is blue so hard?
So blue is hard because when you're making a firework, if you want to make a brighter, more intense color, you heat it to a higher temperature, right? So it kind of goes through the color spectrum. So if you want to burn a more intense red, just heat strontium higher and it will be more intense. If you do that with copper, it breaks down. So it's unstable at higher temperatures. So
Because it's already blue.
yes,
Yes.
it's already blue. So if you try to get a more intense blue, it washes out. You lose the blueness. The best you can ask for from copper is a dim blue. So some people say you can judge a fireworks display by how good of a blue they have.
Oh. I don't love this phrasing in this fact. Most difficult. I mean, everything is decently subjective when you talk about difficulty.
Yeah.
But I get what you're saying. What do you think?
For me, with all the metals and everything, definitely the part about copper checks out. So I think, if not 100%, I think I'm relatively sure about this.
Yeah, I'm feeling good about it.
Yeah.
Wait, backtrack. Copper is why the horseshoe crabs have blue blood, isn't it? Just like iron is the reason we have red blood.
Red blood.
That just hit me just now.
Yeah.
I was like, wait, our blood is red because of iron?
Yeah.
It must be copper.
They have copper in it. Yeah.
Wild. I want to talk a lot more about horseshoe crabs. I
I
don't
know.
care.
We need a sub episode. Yeah.
Okay, so those were some very colorful facts, but one of them is a lie. So we need you to repeat the four of them before Soups and I take our guess at which one it is.
Okay. Fact number 1. Leaves naturally have 3 color pigments. Fact number 2. Litmus tests are made from the blue blood of horseshoe crabs. Fact number 3. The ocean is blue mainly because water absorbs red light. And fact number 4. The most difficult color to create for fireworks is blue, of all the colors that you can make.
Right.
These are like, you'd expect that you should know this.
I
like
know,
these are
right?
such basic facts.
It feels like that.
Yeah. And then it just gets you.
I'm feeling the same way. I'm
Yeah.
feeling like this is some third grade science and I really ought to know which one is the lie, but I don't.
I don't. Me neither. I think number 2.
The crabs?
Maybe it was a thing in the past. I don't know if it's no longer a thing.
I'm with you on that.
Yeah.
That it's like the lie is going to be something hopeful where it's like, no, actually, we don't use them anymore.
Yeah.
But we got burned on that last
Last
with the
time,
sharks.
yeah, I know, right? So maybe it's like a trick.
Why do you keep giving us facts about murdering sea creatures?
So it's like, totally his thing now. Yeah.
I test all my facts on animals. Yeah.
Oh, no. The I should have known is a fully cruelty-free
Yeah.
show.
I'm just so worried about conservation. I always look at where they're dying. I guess.
Okay. And also about this ocean one, I think it's so logical, but there might be like a small important detail
Yeah.
that we just sort of totally skipped.
Yeah, I think I'm going to go with the ocean one
Yeah.
because I think it's way too simple. And I want there to be a way cooler reason why. the
Yeah, I
ocean
know,
is
right?
blue.
Yeah. I'm going with number 2 purely for emotional
Yeah,
reasons.
yes.
Not backed by science, not backed
Yeah.
by logic, but purely
Yeah, I'm going with the ocean. You're going with the crabs.
crabs. Yeah.
Okay. Then we have fact number 2 and fact number 3. Time for the big reveal. The lie is fact number 2. We are not killing crabs every year to make this.
Go emotions.
Yes, wishful thinking.
Yay.
Yeah. Wow.
If you ask NASA why the ocean is blue, they say it's because of the absorption. But
Yeah,
a lot of people are still trying to figure it out.
I mean, it makes
Sense.
obviously it makes sense. I
Yeah.
know how light works,
Yeah.
but I just wanted it to be something cool.
Yeah.
I just
Yeah.
wanted it.
Yeah.
Foolish.
So, fact number 2. The truth is kind of 2 facts put into one. So horseshoe crabs, we do bleed every year.
Oh no, what? No, wait. We were just excited. What, you can't do this to us?
Well, it's a very different reason.
Okay.
But
Hopefully
like,
positive.
Yeah, definitely positive.
Okay.
And it's going in a good direction.
Okay. Let's see. Let's hear him
So-
out. Yeah.
Horseshoe crabs, their blood is not sensitive to pH. It's sensitive to toxic bacteria. So it is bright blue.
is my blood not sensitive to toxic bacteria?
Not in the same way. No.
Okay.
So they have nothing to do with baking soda or any of the color changing stuff. Horseshoe crab blood is used for the Limulus amoebocyte lysate test, which checks new vaccines for contamination.
Oh.
And scientists are working very, very hard to try to clone these cells in the lab so we don't have to bleed them anymore.
Okay, wait, but it's a noble cause.
Yeah.
It's okay.
So it still happens.
Yeah, I know.
But I guess it's not just for like some snot-nosed kids to
Yeah.
like learn chemistry.
Yeah.
It's a little better.
But still, I should have known.
I should have known.
Thanks for listening to this episode of I Should Have Known. We now have YouTube as part of season 4. So if you are listening on YouTube, please like this episode and subscribe and leave a comment. And we'll be continuing with our rainbow theme with more colorful topics for the rest of the month. Next week, we're going to be talking about cuisine. Hope you're hungry for more. And as always, thanks for listening.
Hear those birds?